Okay, so we're looking for sum of all the red lines, okay, in this diagram. So let's start from the one that's the largest. Note that what we have here is a right angle triangle. So note that CD is just B, right? B times by sine of theta. So sine of theta. That's what CD is equal to. Okay, and note that DE, right? DE is going to be, so if this is theta, right? Actually phi. Note that we have that right there is 90. So this actually also is going to be theta, since theta plus phi is 90, because this is 90, which will make this back to phi, and the pattern continues, right? If this is phi, this is theta, phi, theta, and this pattern will continue. So what we have here is, if this is B sine of theta, right? This right here is going to be DE, right? The length of DE over DC is also equal to sine of theta, right? In this DEC triangle. So therefore DE, right, the absolute value, the length of DE is going to be DC or CD times by sine of theta, which is going to be B sine of theta times by another sine of theta, so we get B sine theta squared. And guess what? If you do that for EF, all we have to do is just times by sine of theta again. Okay, so this is going to be 3, next one's going to be to the power of 4, and so on. Okay, so let's actually factor out B sine of theta. Okay, B sine of theta, and we get 1 plus sine of theta plus sine of theta squared, and so on. Okay, so this is our sum. And sine of theta is equal to 1 when it's 90 degrees. But when theta is between 0, and it cannot be 90, so between 0 and 90, sine of theta is going to be between 0 and 1. So it's not going to be 1, right? It's going to be between 0 and 1, which means this right here is an infinite, right? It's an infinite geometric series. So we can say A, which is the first term, over 1 minus R. So our final answer is this. Okay, that's the representation of sum of all the length. Okay, all the red length in this diagram.